in this question, we've been given a sample of carbon and we've been asked to figure out what's the relative atomic mass of this sample. We've been given a mass spectrum of the sample, and the question asks us to give our answer to 2 decimal places. So for these 2 isotopes, how would we initially approach this? Well, the way I'm going to approach this is, first of all, matching the isotopic, the relative isotopic masses with the relative abundances. So first of all, with the carbon-12, what's the relative isotopic, what's the relative abundance of this, right? Well, based on the relative isotopic mass of 12, on the graph, I look for the mass charge, which corresponds. So that would be the one under 12. So we see here, okay, we've got relative abundance of 6. Now, if we take our attention now to the other isotope, the carbon-13, we've got relative isotopic mass of 13. So if we look here, we see there's a peak for 13, which corresponds to a relative abundance of 77. Now from here, we need to actually run the calculation. So we need to calculate, in this case, we'd be multiplying the relative isotopic masses with the relative abundances and adding those together. So really 12 times 6 plus 13 times 77. And I would invite you to take a look at what that comes to. So what you should have come to, if you work that out, is 1073. And so what do we do with this number? Do we divide it by 100? Do we divide it by something else? Well, it's important we don't dive into dividing it by 100 without first checking, well, what does the relative abundance actually add up to? What's the total relative abundance? It's that number which will divide the 1073 by. So in this case, we've got the 6 plus the 77. And what does that give us? Well, that would give us 83. And therefore, in this particular case, what we're actually going to use is 83. We're not going to divide by 100 because the relative abundance, the total relative abundance, is not 100. We're going to divide by 83. So we're going to do 1073 divided by 83. So I'd invite you to have a go at that, see what you come up with. And so if you do run that, what you get is let's just scroll this a bit here. 12.9277, right? Add one there. Right. Now, is this our answer? So the first check which we're going to do is we're going to look at, in this case I'm just going to use placeholder symbol. Let's assume we use an A, right? So let's say our answer is A. What are the mathematical limits we know A should adhere to, just as a sanity check for this question? Well, based on the answer, based on the information given in the question, relative isotopic mass of 12 and a relative isotopic mass of 13, we can reasonably infer that the answer logically speaking, should be greater than or equal to 12 and less than or equal to 13. Realistically speaking, it's not going to be equal to 12 unless the relative abundance of the carbon 13 is 0, and it's not going to be 13 unless the relative abundance of the carbon 12 is 0, right? But we can infer it's going to be within that range. Now, given that, and we look that our answer, well, not our answer, but the number we came up with so far was 12.92771. Is that within this range? Yes, it is. And it also seems relatively appropriate given we've got much more of the carbon 13 than the carbon 12, and we see much more of a lean towards 13 than towards 12. But is this our answer? It isn't yet our answer, because we've been asked here to give it to 2 decimal places, so we do need to adhere to that. So in this case, if we round our answer, well, if we round the number we came up with, which is 12, so what we'd get is 12.93, right? So now the question is this our answer? Is this the relative atomic mass of this sample? In this case, yes, this is our answer. All right.